Hey there, let's build an entire blockchain project in lightning quick speed. In fact, we'll try to build one in less than 10 minutes. This video is going to give you hands-on experience with coding a blockchain right away. We'll create the basic building blocks for a blockchain, but feel free to jump ahead to the actual project in the course if you'd rather start building a more complete version of the blockchain right now. But the idea of this video is to give you the essential coding concepts of the blockchain as quick as reasonably possible. So first up, we need a place where we can code. A great option for a quick environment is Replit. So repl.it/@15decats/lightning chain. When you visit this link, you'll be able to create your own version of this file and start saving your own changes right away. To see how this works, go ahead and add a console.log of hello blockchain in a string. And then press that giant run button and you'll see that the results are in the pane to the right. So we have our hello blockchain output, and then the return value of the console.log is undefined. Cool. So with that, that's how Replit works. Let's now code the blockchain. Fundamentally, a blockchain is a list of linked blocks. Each new block in the chain contains a link to the last block that came before it. That's why it's called a blockchain. It's a chain of links, and it's linking those blocks. So to start, the most basic building block that we need is, well, a block itself. So let's make a JavaScript class called block. This is going to be capitalized, and the body of the class is with a pair of curly braces. By the way, don't worry if you're not familiar with JS just yet. There's an optional mega overview of JavaScript and Node.js later on in this section. In this video, it's more important to focus on the blockchain concepts that are appearing, rather than the details of JS if you're not familiar just yet. Anyway, now that we have this block class, we can define the constructor method for it. The constructor is going to have a data field, a hash field, and a last hash field. Notice that last hash is camel cased, so the H is capitalized. Within the constructor, we can set relevant fields for any instance of this block class. So this .data equals data, this .hash equals hash, this .last hash equals last hash. All right, and this makes it so that when we create a new block, we'll specify a data, hash, and a last hash field. And this will create matching fields for each incoming piece for that actual block instance according to each of those fields that we pass in. For example, we can make a foo block constant. So a constant is a JavaScript variable that can't be reassigned. We'll use the new keyword and the block name to make an instance of the block class. For the data, let's pass in foo data. We'll make a foo hash and then a foo last hash. We're just passing in dummy values for now. And to see the result of this, let's console.log this foo block. Cool. Let's go ahead and run this. And what we get is a block object noted by this block keyword over here, which matches the class name. And the data matches the foo data. The hash is the foo hash that we passed in. And the last hash is the foo last hash. Cool. So now we have our successful block class. That's excellent. But the question is, of course, what do all of these fields in the constructor even mean? What is the data? What is the hash? What is the last hash? Well, first up, the data field. Primarily, the block is a storage unit. Therefore, the data field specifies what the block is storing itself. Second, there's the hash field. The hash field is a value generated for the block by taking the data and cryptographically transforming it. The key is that this hash function consistently generates a unique value for any different data input, even if that data field is only one character off. Later on, other individuals will want to verify that the block data is correct. In the course, we'll dive into this concept way more deeply. Finally, the last hash field creates the link between blocks for the blockchain. By having a field that is set to the hash of the block that came before, well, a link is created between the new block and the last one. Cool. That completes the block class. Our overall next goal is to make a blockchain class, but a prereq to that is to create a hash function. So at the top of the file, let's make a function called lightning hash. Notice that this is camel cased as well, so the H is capitalized. And the idea is to generate a unique value for whatever data comes in. For this Lightning blockchain version, let's do something quick. For a data argument, we're going to return the data plus a star. So we're assuming that this data incoming to the Lightning hash function is a string, and the hash for that is just going to be the data string itself plus an extra star. So it's a very basic hash, but it gets the job done in terms of consistently generating a unique value for unique data input. Again, later on in the course, we're going to have a much more advanced cryptographic hash function, which will have other properties that will make it so you can't even identify what the original data input was for the actual hash function. Cool. Now we're ready to make a blockchain class. Let's go ahead and remove this foo-block experimentation code and replace it with a blockchain class. This has a constructor, and then this will make a local chain field for the blockchain instance. So the constructor has no arguments, but it does have one chain field, which is an array. And the idea is that this blockchain is going to have a list of block instances within this chain array itself. Every new block is going to be based on a prior block. But this does beg an interesting question. What about the very first block in the chain? How does a blockchain create that block if there's nothing that came before? Well, to address this, the blockchain starts with a genesis block. It's an initial hard-coded block created purely to allow the first real added new block to have a prior block to use. So let's make a local genesis block. Let's call this genesis. We're going to use a constant again. This is going to be its own block instance. And again, we'll use dummy values because we need dummy hard-coded values for this genesis block. So we're going to have gen data, gen hash, and then gen last hash as those values. Excellent. And this allows us to start the chain with the genesis block itself as the first item. Cool. Now we can create a generic add block method, which will allow us to add new blocks to an instance of this blockchain class. Let's call this add block, and its only argument will be the data for the block. Nice. So now that the block has its data specified, well, we need the last hash and the hash itself. The last hash we can find. We can look at whatever is the last block in this chain and then create the last hash based off of the stored hash in that block. So let's make a constant of last hash. And to find the last block, well, we need to find the item which is currently at the last position in the chain. So that will be at this.chain.length -1. So we'll access it in this.chain, and then we'll find it at this.chain.length -1, which will always be the last index of the array. And then we can access that item's hash. So that will be the last hash. And then the hash needs to be generated using our hash function. So we'll call lightning hash, we'll pass in the data, but then we'll also pass in the last hash. So that way the hash consists of everything that is a part of the block itself. Cool. Finally, we can create our block, which will consist of all the fields that we found. So first the data, the hash is actually the second argument, and then the last hash argument as the last one. Finally, to add this to the chain, well, we need to call this.chain.push and then add in the block to the chain array. Excellent. Let's explore this now. So we'll make a foo blockchain dummy instance of the blockchain. Let's go ahead and add a block. This first one will consist of a string that says 1. I'll do this one more time with a foo blockchain add block of 2 as well as of 3. And then to check out this whole thing, I'll console.log this foo blockchain. Cool. So once you have all of these changes with the foo blockchain code, or however you called it, and then the blockchain class, more importantly, go ahead and run the file. And cool. Notice that we're under the 10-minute mark, and we've completed this blockchain project in under 10 minutes overall. Awesome. So with that, let's go ahead and check out the output. And what we have is a blockchain class that consists of an array of block instances. First, it's the genesis block with all of its dummy values. And each last hash, notice, matches the hash of the one that came before. The trend continues all the way to the last block, whose last hash matches the hash of the previous block. Very cool. So that completes the entire blockchain class. And as you can see, the fundamental concepts are not so advanced. You have blocks to store data, then you have those links between blocks with the last hashes, and then the blockchain itself, which wraps around all of those blocks. Now, when it comes to the actual blockchain project, it's all the other objects that will add on top of this blockchain and the actual cryptographic methods, as well as things like transactions, wallets, public keys, the blockchain network, the API, the pub sub implementation, as well as the front end and actually deploying it. All of those things will make this blockchain project truly powerful. But in the meantime, we've already built a full blockchain, so great work already. Up next, let's create the full version of this blockchain and cryptocurrency project.